Okay, 6.2. Still factoring, but for 6.2, they factor. For this one, we're going to go with trinomials. And if you haven't done anything with all the polynomials stuff, everything in a while, trinomial just basically means that's 3 terms. Monomial would be 1 term, binomial is 2 terms, trinomial is 3 terms. And once you get past 3, if it's got 4 or 5 or 6 terms, they just call it a polynomial. Just so, because there's a lot of numbers in it. There's a lot of different terms for that thing. And when they talk about trinomials, the basic shape of all the trinomials that they'll get to is this. Ax squared plus bx plus c. And we're going to look at a couple of different things on this. The very first thing that we're going to do for this part that's in 6.2 is they're going to tell you for this one that we kind of get a shortcut for this part. That if your a value is equal to 1, I can write it down here, then we have a shortcut. Okay, and that's where we're back to this sheet again. The left side is where we get to use the shortcut because that's where we have the first term equal to 1 with a value. The right side, that's where we do the a value not equal to 1. And basically is this. And again, this part, it's reverse full method. That we've got the different terms, so when we get finished on this one, we'll come back to it. Here's all we're going to do. We're going to look for the factors of the c term, where the sum would equal the b term. Okay, and that's the whole work that we're doing for this thing. Everything else, and now once we get it finished up to where it needs to be, it'll be just a quick, easy fix, but that's the whole thing that we're going to do for this part to make it work out. Okay, so in 6.2, this would be objective number 1. And they should say factor the trinomial. There shouldn't be anything at all about the greatest common factor. It should just be, here we go, we're going to factor. So we'll go with z squared plus 5z plus 6. Okay, and again, your a value is 1, your b value is 5, and your c value would be 6. So a is 1, b is 5, and c is 6. And basically it's this. It's the factors of 6. Okay, give me all the factors. There's not many, right? It's either 1 times 6 or it's 2 times 3. Now, with these, when we do the factors, you have to list them off in pairs. You've got to tell me that, okay, if I'm going to get 6, I can either do 1 times 6 or I got to get 2 times 3. So they're always kind of attached together in pairs. And you're looking for the pair that the sum is going to add up to be the b term, which is, and put the signs on these two. Positive 5. Well, the only way that this adds up to be 5, because 1 plus 6 is 7, you've got the 2 and the 3. So 2 and 3 is the pair that we're looking for. Okay, now, to get the answer back in factored form, here's all that we're going to do. Because to get z squared, that would be z times z. So again, we're basically doing reverse full method. So there's our 2 parentheses. This is z squared, so that's going to be z times z. If you do the first times the first, that's z times z. That's where we're going to get our z squared. So that's kind of going through that part. The o and the I part is basically these two numbers. So whatever these two numbers are, that's what we're going to get put back in here. So if you want to check it, not that you have to, unless you just want to check and see. If we went back and checked it here, we have z times z would be z squared. Z times 3 would be 3z. You don't have to write this down because you can kind of watch and see. 2 times z is 2z. and then 2 times 3 is 6. There's our z squared. 2 plus 3 is 5. And we've got our plus 6. So if you need to check it, that's all you're going to do is just go back and do the full method. And if you do the full method and the numbers come back to here, you've got what you're looking for. Okay, so for the second one, let's do y squared plus 11y plus 30. Again, all these first ones, they all have the shortcut where a is 1, b will go with 11, and c will go with 30. Again, we'll put a plus there. We can go back and put the pluses. So it's the factors of positive 30. And then just go back through and list them real quick. It's 1 times 30. It's 2 times 15. It's 3 times 10. Or it's 5 times 6. And we want the sum to be 11. Okay, check your pairs. And real quick, there's the 5 and the 6. Because 5 plus 6 would make it out to be 11. So when they ask you to factor, it's just y plus 5 and y plus 6. And it doesn't matter, some people always ask, well, does it matter which number we put first? No, as long as you've got a plus 5 and a plus 6, whether you put which one first, it doesn't matter how you go with the numbers there. Okay, and as long as everything is positive, we're good to go. There's not really anything, there's no tricks to this thing. I don't think they should give you any. The only thing that they could possibly do that I don't think they're going to do is they may give you one where it's prime, where that there are no factors of 30 that would add up to 11. You know, if they change this to 14, if you go back and check your list, you're like, well, 5 plus 6 is 11, that's 13, that's 17, that's 31. That's when you know it's prime. There's nothing you can do. Now, you shouldn't get any of those. But that would be the one case where they would do that. But again, every problem I looked at, I did not see where that popped up. But that could be an option if you're actually going to work through this thing. Okay, now let's give you one with some negatives, because that's going to change things up just a little bit. So let's go with y squared minus y minus 20. Okay, when you get the negatives, it makes things a little bit more difficult, but put it right in the middle so that you can kind of tell that here's where everything's kind of spinning off this one. You're still going to set it the same way. It's still the factors of negative 20. But we need the sum to be negative 1, which means the numbers are going to have to, if it's a negative number, the only way to get a negative number is that you have to have one negative and one positive. If you had two negatives and multiply together to make it a positive, you know, in all the problems we did back here, if the numbers were positive, well, positive times a positive is a positive. You know, so no matter what we did with these, we're going to have the same thing. So go ahead and list your numbers. You've got 1 and 20, you've got 2 and 10, and then we've got 4 and 5. Okay, and then the whole catch that this spins on for all the factoring that we're going to do with any trinomial, no matter what you do, the sign of the b term always, and we've got that in the box here on that paper, that it always goes with the biggest number, with the biggest factor. And I didn't leave myself enough room here. Let's just say the bigger factor. Okay, and always always tell people, and people will word it different ways, and they talk about, well, no, this one's bigger because this. Okay, but when we check it, before you do anything with the signs, just give me the factors. And if this b term is negative, if you have these listed off here, whatever the bigger factor is of this pair, the bigger number's got to be negative. So 2 and negative 10, that number's got to be negative. 4 and negative 5, that number's got to be negative. Okay, now, and here's where it kind of depends on how you set this up. The sign of the other number is basically, all right, since you're going to take negative 20 and divide it by negative 20, what happens when you divide a negative by a negative? Makes the other number a positive. So when you divide these two numbers, it tells you what this sign's going to be. So if this one's negative, that would be positive. Negative by negative makes that one to be a positive. Okay, so now we know which ones we're looking for. For the sum to be negative 1, it's got to be a negative 4. Sorry, a negative 5, and then a positive 4. Okay, and same thing we talked about before. It doesn't matter where you put the 4 and the 5. It does matter that if you put the 5 first, you do have to put the negative with it. So either one of those two is okay, but it's very sign specific that if you get the 5 and the 4, if you make this one positive and this one negative, it's going to be wrong. Because if you put those numbers together, that would make the b term out to be a positive one and not a negative one. Because the bigger factor always carries the sign that it has back into the problem. Okay, let's do a couple more of those. Okay, let's go with x squared plus 7x minus 18. So over this one, we're looking for the factors of negative 18. We want the sum to equal a positive 7. Okay. And just for me, just force of habit, I always put the smaller factor first and the bigger one second, just so that when I go back and put the signs in, they'll follow the same pattern all the way down. Again, key thing on this one is that the b term is positive, so that sign has to go with the bigger factor. And if you divide a negative and a positive, that makes the other number a negative. So bigger number is always going to be positive, smaller number is always negative. And now we're looking for the pair that adds up to positive 7. It's got to be the 2 and the 9. Okay, so it's got to be x plus 2 and x plus 9. And again, where you put the order on that one, it's fine. As long as you've got an x minus 2 and an x plus 9, which one goes first, it doesn't matter. It's the same answer either way. All right, and one more of those. Okay, let's go with x squared minus 14x plus 40. That's weird. Zero. Okay, so it's the factors of positive 40, and the sum has got to be negative 14. Okay, 40 seems like you'd have a lot, but when you go back and check it, there's really not that many. It's 1 and 40, it's 2 and 20, 4 and 10, 5 and 8, and you know, if you check 6 or 7, there's nothing here. If you get back to this number, you've pretty much gotten all the numbers you can do. Now, here's the one thing I will say. If you break this down and you get to this one, and you go back and look and you go, well, none of these numbers add up to 14, that means you probably skipped a pair. There's probably something in there you could have done to divide by some different number. So go back and check all your factors. You know, if you get some number and you're not really sure, if you go through, you know, if you're doing the factors of 72 and you check it and none of the numbers add up to 14, that's where you just have to go back and check all your numbers. You know, take 72, you may have missed 6 times 12. You might have missed 8 times 9. You might have missed 3 times 24. So that's one of those that if you're not sure what the factors are, just take the number and start dividing it. Divide it by 2. You know, so then you get a factor. Divide it by 3. That comes out to 24. You know, if you divide it by 4, that would have been 18. Of course, you can't divide it by 5. You know, if you had 72 and you divide it by 6, that would be 12. You know, if you take 72 and divide it by 7, it comes out to like 10.1874. So if you get any kind of decimal number, it's not a factor. You know, you can skip it and go on to the next one. That's the only thing I can think of that might possibly happen as you work through these. So if you go through this list and none of these numbers add up to be 14, you skip the pair. There's something in there that you need to divide by that you missed, so then just go back and check it and see what the numbers are. Okay, here's the main thing. The B term is negative. That sign has to go with the bigger number. But what's a positive divided by a negative? It's a negative, right? So in this case, both numbers have to be negative. Okay, and the pair that will get you to 14 is the 4 and the 10. Oh, sorry, no, x squared. Let's go with x minus 4 and then x minus 10. Okay, so it's a small thing, and I don't know for these that they always tell you, and sometimes I've gotten where I don't always look at the way the book explains it, because sometimes they do some weird stuff and they talk about, you know, these categories. Well, if your B is this, you do this, and if your C is this, then you do that. But if your B is this and your C is this, then you do, and it's like, no. Don't do all that. It's really just one simple thing. You're finding the factors of the C term that equal the B term, and the one thing that you do no matter what, whatever this sign is, that always goes with the bigger factor. And then you just divide these two numbers to figure out what that sign is going to be. It's a lot easier than the way that we had to learn it way back when. Okay, so that's the first objective in 6.2. The second objective that they give to you is basically it's the same thing. The only thing they do with objective 2 is they give you two variables. So it's going to start with something like this: x squared plus 10x, but instead of just leaving it as 10x, I can put a y or z or some other variable behind it, and then we've got 16 y squared. Okay, now, the setup is still the exact same thing. You're still not going to do anything different. Your a value is still 1. Your b value is still positive 10. Your c value is still positive 16. So setup's still going to be the same thing. We're still going to find the factors of positive 16. Where the sum is going to equal positive 10. Now, and the good thing is, again, if all the numbers are positive, you don't have to worry about the signs, because when you get to the end, it's always going to be something plus something and something plus something. So if all the terms are positive, there is no worrying about which sign is which. Everything is positive because everything is positive. If you get one negative, that's when you got a little bit more to worry about. But if they're all positive, you really don't have to worry about it. Okay, so 1 and 16, 2 and 8, or 4 and 4, and again, everything is positive. So your factors of, to get to 10, well, it's going to be the 2 and the 8. Okay, the only thing you do different is it's still going to be x plus 2. It's still going to be x plus 8. The only thing you do different is on the numbers that's on the end. Since this is y squared, you just go back and put y's on the second numbers. whatever these factors are, you just attach a y, or whatever variable they give to you, just attach that to the factors. I hate to say attach, but I guess that's the best way to say it. Attach the second variable to the factors of b. So once you find the list that you get here again, you just go back and just add on whatever variable they give to you. It's still the exact same thing. It just looks a little bit different because you do have the two variables. But as far as how it works, it's the exact same thing. There's really nothing different about it. All right, let's give you at least one more here. If we need to do another one after that, we can. Okay, so let's go with x squared minus 12xz and then plus 35z squared. Okay, same setup. Again, just ignore the second variable for a minute. C is positive 35, and our B is negative 12. Okay, for 35, there's really only a couple options. It's either 1 times 35 or it's 5 times 7. You can check all the other factors, nothing works. That's the only two options you get. Okay, and again, your B term is negative, so the bigger number has to be negative. And to get the sign of the other number, a positive divided by negative is a negative, so that makes the one negative, so in this case they're both a negative. Okay. And the pair that adds to negative 12 is the negative 5 and the negative 7. So that's x minus 5. But again, because we got the z here, we'll just go back and put a z here. And x minus 7, and put the z there. Okay, and then the third objective, last one that's in 6.2. Is you're still going to factor, you're still going to go through the steps on this one. The only thing they're going to have you do different with this one is that your first term is not going to be 1. So that basically on this one, you're going to be factoring out a greatest common factor and then factor the trinomial. Oh, let's say factor out a constant. So now, even though it's the constant, it's still the greatest common factor. So you're going to factor out the constant before factoring the quadratic. Okay, so we'll go with 6w squared minus 42w plus 54. Okay, so one like this, they're going to tell you, okay, there is a greatest common factor that you have to take out. So if you go back through 6, 42, and 54, now here's the hint with this one. The way they kind of set this one up, and you can go back and check the numbers, your smallest number is what you've got to work on. So the only way you can get 6, it's either 1 times 6 or it's 2 times 3. For these problems, more than likely, I would go back and just see if you can divide everything by 6. There's a good chance that you can, because, you know, if you check with 6, 6 will go into 6, of course. 6 will go into 42, 6 will go into 54. So all you're going to do is take out the 6 first and make it w squared. 42 divided by 6 is 7. And then 54 divided by 6 is 9. So for that one, your greatest common factor would be 6. Okay. Now, somebody may say, what about the w's? Well, this one has 2, this one has 1, this one doesn't have any. So if this one doesn't have any w's in it, you cannot factor a w out of it because there's not one there to take away. So there's our greatest common factor. Now, once you get it here, it's supposed to factor from there. But that one doesn't factor because there are no factors of 9 that equal 7. So, when I was checking this homework, they must have goofed on this. I pulled this one straight from the textbook. That one's supposed to factor. So let's do this. It's going to be easier. Cool. Let's go with this. They goofed on their numbers. Let's make that a 60. So that we can make that a 10. Sorry about that. So I pulled this one straight from one of the problems, and it's supposed to factor from here, but it didn't. So they goofed on that problem. Let me make that. Okay, because before, if that was 9, there are no factors of 9 that's going to equal 7, because it's either 3 times 3 or it's 1 times 9. There's no way to get there. 10, that one we can actually work with it now. So once you factor this part out, now you've got an a value of 1. You've got a b of negative 7, and you've got a c that's positive 10. Now, and the 6 is just out front, so it's just kind of hanging out because it's the greatest common factor. We've taken it out, so it's really not a part of this trinomial anymore once we've factored it out. So it's the factors of positive 10, where the sum is going to equal negative 7. Okay. Again, only one choice. There's only way you can get 7 with 10 on this thing, 1 and 10 or 2 and 5. Okay, so your sign here is a negative, which again, b term has to go with the bigger number, so that's a negative. Positive divided by negative makes them both negatives. So final answer is, the only difference is you're going to put the 6 on the outside, and then you'll put the w minus 2, and then you'll put the w minus 5. Okay, so when I tell you to do the greatest common factor, you're going to, or in this case the constant, you're just going to pull that number out front, and everything else behind it's going to be the exact same question. All right, let's do one more of those. Okay, so let's go with 5v squared. Let's go with a minus 15v minus 9. and again, they go ahead and tell you that you're going to be factoring out the constant, so we're going to go ahead and check it. We can divide them all by 5. So it makes it v squared minus 3v minus 18. Okay, so we're looking for the factors of negative 18. That's going to have a sum of negative 3. Okay, and there's not that many options. It's 1 times 18, it's 2 times 9, or it's 3 times 6. And again, the main thing for this one is that the b term is negative. So that sign has to go with a bigger factor. And if you do a negative by negative, it makes that a positive. Okay, and the pair that adds up to negative 3, that's going to have to be the positive 3 and the negative 6. Sorry, not v squared, but just v plus 3. And then v minus 6. And then the 5 would be up front.